to the first codeHarbour of 2019. So I'm Alex and I've taken over codeHarbour. Let's start off by thanking Porterhouse for hosting and the Creative Foundation for sponsoring. So all the pizzas and the drinks, that's on there. Thank you. So our first speaker tonight is consultant and university lecturer Bob Eager. So take it away.
Hello, I'm going to stand this side actually, not because of the microphone, but because I can't really see very well on my left side. So I'm sorry if I'm behind a pillar for some of you. I'll see how I go. I'll try that side so I'll manage. Yeah. Right, so some of you know me already, but for those of you who don't, my name is Bob Eager. I spent 40 years now teaching in universities and just about stopped this last month. And in my spare time I play with stupidly old computers and just basically nerdy things. So this is the story of the telephone system I put in at home, but I use home a lot for office type work. I've done consultancy for various companies, people like Dun & Bradstreet, Pfizer's, smaller companies, and so I've done a lot of work actually at home, and so I wanted to have absolutely everything that was going to be useful to me in a phone system over the years. And when we first moved into our house, it was completely unsuitable. So this is the story of the phone system. It's a slightly truncated version from the one I normally give, but we'll see how it goes. So I'm just going to give you an overview of it, and I'll skip fairly quickly through this summary here. But I'm going to look at the history of what I've been doing with the phone system, where I am now, just say a little bit about security, and about where you can save money basically as well. And then time for questions, I hope. So off we go. So our house is a nominally 5-bedroom house on 2 floors, but what we decided to do is turn one of the big bedrooms, it's got 2 really big bedrooms, into an office. It's got 2 enormous desks, and it's got a server rack, bookcases, lots of drawers, filing stuff, everything else. It's got 3 reception rooms downstairs, and I managed to convince my wife by devious means to let me have it as a workshop, one of them. So I've got everything in there, and it's got kitchen and bathroom, everything else. And it's me, my wife, and 2 children who are now relatively grown up, but they're still at home, unfortunately, 22 and 24. So the house is a weird layout. It was built originally with a space for a car to drive through the middle because the guy was very rich. This is 1903. You can't hear people calling from other parts of the house. So if you answer the phone upstairs, there's no way anybody in the living room is ever going to hear you. And this would apply to a lot of offices. You know, you've got little cubicles, you've got other parts of the building where you might have a problem. So having a phone system that does things for you is really useful. So just before we developed the telephone system, we rewired the house completely. That was me. I rewired it for mains, burglar alarm, for TV, for Ethernet, for the phones, everything. And I put at least 1 analog phone socket, ordinary BT style socket, in every room. There were 3 in the living room because I wanted 1 behind the TV in case we ever got a skybox, but we managed to avoid that. And I don't know if any of you know what a Chrome box is. These little things here might look familiar. If you see somebody who's got a green cabinet open on the street, there are loads of those in there. I think BT have now bought about 30 million of them. But this is a box with 10 in, and it makes it really easy to do cross connections and to parallel up different parts of the phone system. Every room's got at least 1 network socket. There are 27 in total around the house, and there are some in the workshop's only got 2 because it's got 2 switches in there as well. And all the cables go back to a rack upstairs, which has got two big switches in it. So we started off with what's called POTS. POTS is plain old telephone system. It's a thing that's been around since the GPO started. Conventional landline. And when we moved in, there was a landline with 1 phone socket upstairs and 1 phone socket downstairs, which wasn't terribly useful. And obviously being only 1 actual line, we're talking dial-up, so we were getting a really slow data rate, and if you were doing that, you tied up the phone. So my mother-in-law was always complaining she couldn't get through, and so on. Anybody remember Home Highway? A couple of people? Yeah, right. Home Highway was a way of doing it with ISDN. Modified ISDN, which was sort of hacked around to give you 2 simultaneous voice calls on different numbers, or a voice call and one data call, which was 64 kilobits per second, so it was actually a proper data channel. Or you can make 128 kilobit data call by combining the two. But you got charged by BT for 2 calls. It's quite expensive. It was expensive to rent, expensive to run. So we used that for a while, and I could see the writing on the wall that BT were going to get rid of Home Highway, as indeed they did. So I decided I'd better move on. So I thought it'd be really nice if we had a little private branch exchange, PBX, inside the house. And these are really expensive, and they tend to attract lots and lots of maintenance charges and things. So the cheaper way was to get an ISDN line in, a proper one. ISDN, for those of you who don't know, is Integrated Services Digital Network. They're now getting rid of it. And a little PDX for that, with just 6 lines on it. And the lines were fine. I bought the exchange of eBay for about 50 quid. And connected it up to the wiring centre. I was able to connect different extensions around the house. So there's a living room, kitchen, bedrooms and so on. And it worked pretty well, but it was expensive to run. It was also really hard to get installed because BT don't understand that anybody in a residential property would ever want to have ISDN. And you have to go to their business people, you have to pay a business charge, and you have to pay business call charges, which are far more expensive. So no friends and family, no special discounts or anything. So it was also pretty unreliable. We found that those exchanges tended to blow up 1 or 2 lines and then they didn't work anymore. So I bought about 3 off eBay and then I gave up. So I decided to move to voice over IP, and that's really what this is all about tonight. So voice over IP, for those of you who don't know, uses a network, usually the internet, but it can just be a network around your building if you want, to carry conversations which have been digitised. And the details of that I'm not going to go into. And you either have some software, what's called an IP soft phone, which you can get free ones. I use VoIP, but there are others around, which you can download onto your tablet, onto your phone, onto your PC, and that will connect to the network and allow you to just use it like a phone, as long as you've got a microphone and a speaker. Or you can buy some hardware, a real IP phone, and IP phones, I think the ones I bought were about 30 quid and 50 quid, depending on the sort that I bought. And you just plug that into the network and you can use it straight away, as long as you've got an account. So if you want to make calls outside the house or to another IP phone, you're going to have some way of connecting to the conventional telephone network. And the way you do that is by paying money, or at least having an account with what's called an ITSP. That's Internet Telephony Service Provider. And the ITSP might be just somebody like VoIP Cheap, who do it very, very cheaply indeed. There are 1 or 2 free ones that have been around in the past. Better to go for one that's well known and stable. Is unlikely to suddenly say, oh, we're only doing business, or we're shutting down because we're not making any money or whatever. My ITSP is actually my ISP. It's the same people, and they provide everything for me now. So if you want to make an outgoing call, your soft phone, you can just install a soft phone on your PC to try this out. You don't need to go and invest any money to start with. Install a soft phone on your PC or whatever, and you have to set up the account on there from your ITSP, which is just a username and password, and they will give you a phone number. When you make an outgoing call, it goes to your ITSP, who then connects it through to the main phone network. And the caller ID people get is the number that the ITSP have given you. So it's just like an ordinary phone call. Incoming calls come via your provider to that number, and then they get routed through to you on that particular device. Now, the interesting thing about this is the way that works. When you start up a device and you start up, say, a soft phone, it registers with the ITSP and says, look, I'm over here, this is this number, this account. And then calls come to that. But your device could be anywhere. I could take my laptop to South America and connect to my ITSP over the internet and say, here I am, and they would call my Canterbury number, and it would come out on here. So it's a very portable way of doing phone calls. You can make phone calls that appear to be from Canterbury or from a posh address in London. In fact, they're from some grotty little hovel that you've got in there. I won't say where because that's probably upset people. So you can keep moving around, and that's the nice thing about having a soft phone with this. You can change that registration frequently. You can also register more than one device with some ITSPs, and it will send the call to all of them, and then you pick up whichever one's most convenient. So that's a simple way of doing it, and that's the way you can go away from here tonight and you can try this out. You can actually do some sort of rather nice experiment just to see whether you make a phone call over the internet. Right, so phase one of what I tried to do was to set up a dedicated PC. So I got an old PC and I used this software called Asterisk. Now this is actually set up not just one phone but many phones in the house, so they can talk to each other and also talk to the outside world. And the software is the only one really that's in the game, which is something called Asterisk. Now you can buy commercial versions of Asterisk for a price together with maintenance and everything else, or you can go and get the free open source version, install it on Linux or BSD or whatever. It's very well proven, it's well documented. There's a superb book on it which you can buy, and there's plenty of online documentation. So this all changes slightly now. What happens is that Asterisk itself registers to the ITSP and says, hey, we're over here, send all your calls through to here. And Asterisk can register multiple numbers. So any of those numbers get routed into Asterisk, and then Asterisk decides what to do with them based on what you've told it. And then it will route calls to individual phones, which effectively register to Asterisk. There's a two-level registration. All your phones in your office or house, like mine, register to Asterisk and say, we're over here with this particular phone, and then Asterisk itself registers to get the incoming calls. The way they register to Asterisk depends exactly on how they're connected. Some are going to be soft phones, some are going to be hardware phones. So, how did I communicate with the analog world? What if I wanted to make an outgoing call from a phone on my PBX, but I wanted to make it out on the ordinary landline? Well, there was a little PCI card to plug into a PC, and my PCs had one PCI slot in them. They were little one-use servers. And that interfaced with the normal POTS line, so you could actually get which we need anyway to get the ADSL in. And that was supplied by the people who actually originated Asterisk. They originated Asterisk partly to make money selling the hardware. And this card had a port on it called an FXO port. That's a term which derives from the USA. It's a port that communicates with the central office, which is what they call a telephone exchange. And that was all I needed for that part of it. And then to talk to my at this point I only had analog phones in the house still, the same analog phones I'd always had. I had a thing called ATAs, which are analog telephone adapters. It's a box, it's got a load of phone sockets on the back, and it's got an Ethernet socket. So you connect that to your network. Asterisk routes all the calls for all those phones through the Ethernet into that box, and then that box sends the calls off to the right phones. And originally that was done by a firm called Sapura. They were taken over by Linksys, and now Cisco market them, but the boxes are still around. And they have ports on them, obviously, to communicate with the telephone, and they're called FXS ports, which means they communicate with a station, which to you and I is a phone. Now, they're also called communication endpoints, but when you go and look up things for phones on the Cisco site, you have to look at communication endpoints, or you won't find it. So that was all okay, but the PC was quite power hungry, and it was quite noisy. And I've got tinnitus already from years of working in computer rooms. So I replaced the PC with an HP microserver. HP microservers, if you pick them at the right time, are cheap, and I got a bit addicted really. You can pick them up with cash back for about £100 at times, usually for about the 6 months before they bring in a new generation of them. And I have 13 of them. Not all in use. I'm using 6 at the moment for various things. And one of those has handled about 10 simultaneous phone calls because we tried to stress it easily, so no problem there. And all the phones went through an ATA, so they're ordinary phones in the house, various old phones we had, and just by this multi-port, in this case, an analog adapter, it had 8 phone sockets on it and an Ethernet port. And it worked well, but that ATA with the 8 phone sockets and Ethernet port was power hungry. It was also noisy, and the fans wore out after about 9 months. I got fed up with taking it apart and putting a new fan in. And it also lacked facilities that I wanted. So in the end I thought, bite the bullet, let's just go all IP and get rid of the analog phones. So replaced all the internal phones with Harbour IP phones, and the house was already wired for gigabit Ethernet, so it was trivial to do that. And one of the nice things about phones is that they've got, some of them have got an internal switch with an extra port on them. So you can keep your PC plugged in anyway. And I chose, I kept one analog adapter to interface with the real phone line, so we could still make calls out on that number and receive calls on that number. We very rarely did. I think the only people who ever use the analog phone line are the Chinese takeaway. But that's going to change. And I bought 10 phones in the end. Cisco phones, 30 quid, 50 quid, depending on what they are. They're really quite easy to configure. They've got a rather mind-boggling web interface with about 10 tabs on some of them. But you can configure absolutely anything you want. But what I do is I make up an XML file with a script and just feed that into the phone, and then it all works. I've got a block of 10 consecutive Canterbury numbers by ITSP, some nice numbers. And I'm using 8 of those at the moment. So I've got 1 as a general house number. I've got 4 as personal numbers for each family member. I've got 1 for what's called memo service, 1 for the remote door unlocking, and 1 for the 3G shed alarms. We'll come to that. And I know this doesn't apply to an office, but I think it gives you an idea of the breadth of what you can do using this kind of stuff. You really have got an awful lot of options. It requires programming, but the programming a dial plan, as it's called, is really quite simple. It doesn't require a great deal of effort, and if you can write a shell script or something similar, you can write this. So internal calls to another phone in the house ring with a single ring cadence, the sort of thing you often get from an internal call. The house number rings with a normal cadence. Calls to the personal numbers for each of the 4 people in the house ring with a cadence corresponding to the Morse code for their initial. Because I couldn't think of anything else. And no, they don't know Morse, but they know their own. The only person who ever gets confused is my wife. We've got shed alarms which can ring in from the various sheds that we have in the garden, because we were having trouble with that. We had a burglary. And they've got they can actually call in. They've got GSM alarms, so they can call in. And if any of those are detected, it rings with a cadence of SOS. And the other 2 numbers actually don't cause the phone to ring. They do weird things. So 1 more cadence we use for another purpose, but I'll come to that. The current system is still the HP microserver. I run FreeBSD. I don't use Linux. Jumped up Unix wannabe, in my opinion. But then I've been using BSD since 1977. It runs Asterisk, of course, Asterisk 13 at the moment. I keep slightly behind the bleeding edge. It's got 1 these Cisco Secura adapters, and all that's for is just for running the bell. That bell there, which sits out in the garden, so we can hear phone calls in the garden if we need it, or anything else that the PBX wants to tell us. 10 IP phones, 1 external POTS line which we use for the broadband, and we could in theory use for phone calls. We've got the network, and we've got some other bits of home-built hardware, which I'll come to. And out the box, Asterisk does a great deal. If you want to add a bit more to it, it's very easy to do so. You can add scripts to it, you can make it call programs, you can make it do anything you want, really, as we'll see. So we've got textual caller ID on the phones. It looks up people's phone numbers. Once you know somebody's phone number and you know they're likely to call you, you can stick that into the dial plan, and it will then put their actual name up, or whatever description you have for them, which might not be polite, but you can come up on the phone. You can have voicemail, separate voicemail boxes for each of the numbers, and the voicemail is indicated by a red light on the phones. What I've chosen to do here is have the voicemail announced to the phones that are personal to those people. So in the case of a voicemail to the house phones, they all go on. In the case of a voicemail to me, it goes on my office phone, and with the sons, it goes on in their bedroom phones and so on. Short code dialing, 3-digit numbers to dial all the common things, and you soon learn the ones you know. I mean, the most important is 312, which is the Chinese takeaway, right, which I dial quite often. And it just means the phone book's in one place. The 3-digit things are easy to remember. We do have a list of them by each phone, but people rarely need them. Call recording, you just dial #3 and it starts recording the call. Selective ringing, depending on the number called and the time of day. My older son used to get late night calls from a bunny boiler ex-girlfriend, and she used to ring at 1 in the morning, and of course all the phones went off. So our son's numbers now only ring their room. They ring 6 rings on their own phone, and then tell the caller we're now trying the rest of the house. Very useful, saves us being hassled. Call parking. I can answer a call downstairs in the living room, and if it's somebody I need to refer to something in the office, I can park the call by dialing a number, go upstairs and dial the number I've been told by the phone, and pick up the same call, which is being held for me. Very useful. Call pickup, I can pick up another ringing extension, so if I know somebody's out but I can hear their phone ringing, I can pick it up. Internal paging. There's 4 numbers, 401, 402, 403 and 404, corresponding to the 4 people in the house. I can dial one of those and it will ring all the phones in the house with their cadence, and that means that no matter where they are, they'll pick the phone up. If my son's having a quiet cigarette in the garden, he'll come running in and pick up the kitchen phone. A speaking clock, I had to put that in because my sons were starting to use the real speaking clock and it was costing a fortune, so that overrides it. Caller blacklisting, which is what it says. Once you know as a bunny boiler ex-girlfriend, you can blacklist their number. Caller just told you you are blacklisted, click. Caller grey listing, which is really evil. What this does is the caller hears several rings and then is sent to voicemail. The phone doesn't actually ring. You don't hear anything, right? And they don't realise that. Every time. So if it's somebody, we have 1 or 2 people who ring us up only ever when they want something, they can never get through. But they don't actually get told they're blacklisted. That was my idea, and I'm quite proud of that. It's very useful. Additional features of memo service. There's one external number which could be dialed from anywhere, and it's got an internal equivalent. And I use it quite often from the kitchen, 130, to send myself an email with a voice message. Usually it's something about what needs to go on the shopping list. And the voice file gets emailed as an attachment. So while I was driving down here, I thought of something I've got to do tomorrow. So just get the car phone, click hands-free, and ring the memo service and tell it what I need to remind myself of. The doorbell. Bell push on the front door. Big house, big problem with hearing the door knocker. So there's a sign on the door that says, always use the bell. We need this because, as you probably know, all the parcel force men are the people who, when they were kids, used to ring the doorbell and run away. Now they become parcel force delivery drivers. And so what happens here is the bell push on the front door goes to a microcontroller, which sends a message via USB to a process running on the exchange, which then queues a phone call. And the phone call rings with a special urgent cadence, which is repeated, so we can hear the doorbell literally in any room in the house. If you want to go and have a sleep at a time when somebody's likely to be calling, but it's not for you, then you can do various things. You can enter a code on the phone and tell it to so perhaps hush the phone for 90 minutes for doorbell. And that's also done when my sons decide they want a 1 o'clock in the morning pizza delivery, for example. It means we can go to sleep, and they're very good about actually setting that up. The door lock. The front door lock can be operated by a USB-operated electrical relay. You've seen these things that people use in blocks of flats. Similar kind of thing, but here you just dial 666 on any phone and it unlocks the front door. That's because it's designed for my sons, and I thought 666 was appropriate. They were coming home from work at a restaurant at 1 o'clock in the morning, or even later, and they were forgetting their keys. I thought, sod that, at least I don't have to get out of bed now. Then I improved that. You can make a call to one of the external numbers, and as long as you give both factors of the authentication, you can unlock the front door. I got a phone call when I was, my wife and I had a weekend in Brighton last November, and while there we got a phone call from the younger son who'd forgotten his keys, gone out to his car, forgotten to take his keys with him, come back, door's locked, his brother's flat out in bed after a 10-hour shift at work, and he couldn't get in. So from our hotel in Brighton I was able to unlock the door for him. It's quite useful. Because he'd forgotten the passcodes, otherwise he could have done it. My wife was worried about that, but remember, this little flat bit of metal that you put in the door still works. Call filtering. If anyone withholds caller ID, they get a menu, and they have to answer the right things. Most of the menu options just toy with the caller and do silly things with them. If the sound works, I can show you one in a moment. The last option lets the caller through, but the very first thing that happens when the phone is picked up by the exchange is that it plays the tritone, the intercept special information tone. And what that does is tell any automatic equipment, this phone line is not in use. So it probably won't ring again. Alarm calls, you can book an alarm call for any time. So I was really tired this afternoon, I had a bad night last night. So I went for a lie down and I set the alarm call to wake me up in time to get me here. There's an external bell in the garden which you can turn on, it's off by default. You just dial *61 and it turns it on, *600 turns it off, and it deactivates at 8 PM to avoid annoying neighbours. So I have moved using exclusively voice over IP. I still have a BT phone line, but only until next week, and that's being moved to my ITSP as well. It's cheaper. I hate BT, so it's all good. BT call charges, if you pay the call charges, don't have a package. Typically 15 pence a minute for a landline and a 23 pence call setup fee. Ridiculous. The call package isn't economic for the amount of calls we make. The ITSP charges 2 pence a minute, and after the first minute it's actually fractional. International calls are really, really cheap compared to BT. If you're going to do this, make sure that you pay a lot of attention to security. What you don't want is a PBX that somebody can dial into from outside and can then make outgoing calls, because obviously they can cost you a great deal of money. So you have to be very careful that incoming calls go into the right environment which doesn't allow outgoing calls. Easy enough to do. There we are. There are scripts you can do which wait for the caller to go silent and then just say something innocuous. So they'll do things like wait for silence, say, yes, I see, and then the caller will say something else, then go silent, say, can you tell me more? There are scripts that will keep people going for 20 minutes, right? Just saying innocuous things. And there are longer sound files that tie callers up that can be amusing. I'll try and play this one if I can, just to finish off. But I'm not sure if it's going to work with the speakers. So. No, it's not. The sound system is not working here for that, so I can't do that. But essentially it's about a 2 or 3 minute thing which says, thank you for calling, it keeps you in a queue. And then the person at the other end gets quite sort of emotional and says, look, I shouldn't be telling you this, but actually you're never going to get through. And it's probably going to be the cleaner picking up the phone tonight. The menu system, if I could play that, says, if you are a telemarketer, press 1. And then it says something along the lines of, sorry, all members of the household are currently assisting other telemarketers. You're in a queue, please wait. And various other things like that. If you've won a holiday, press 2. If we are conducting a survey, press 3. At which point it says, well, our charges for answering surveys is £10 a minute. Please give a place where you can send the pro forma invoice. So there are lots of things you can do there to play with people. But you can see with this range of facilities, you can do a great deal with voice over IP that you could use in an office for all sorts of wonderful things. So it's quite over the top for a house, isn't it? But that's me. Sorry, that's the way I am. Alex knows that. if you've got a SOHO situation, I mean, I do use quite a bit of it. It's great fun. It requires very little maintenance. The only time I ever go and do things with it is when I'm adding new numbers to the list for caller ID or the blacklist or whatever. It may or may not save money, but it certainly doesn't cost any, apart from the initial capital expenditure. You don't need a powerful system. People actually run it on a Raspberry Pi. Right? You can go down to that level. As long as you've got USB and Ethernet, that's all you need really. And that will support a few extensions. And you can try it out without compromising all your existing phone system. Just get yourself a soft phone, try it out, and if you like it, get yourself a proper phone and use that. So, that's it. Any questions? Yes?
I've got a couple actually. How do you see this fitting in with technologies such as artificial intelligence to promote conversation?
You could put a lot of programs behind this to do whatever you wanted with a call. Yes, and people have already. And you can see also you could use this for actually making calls out, marketing calls. I mean, this is how these things work. So you could do whatever you wanted. Anything that can be programmed can be linked into this. Anyone else? Go on then.
Okay, so you said how you really dislike BT. I couldn't agree more. With my organisation, we're going completely data dongles, so devices with data. How do you see that sort of reflecting VoIP and also the future of VoIP with things such as Skype and video calling and Hangouts and so forth?
Well, yeah, I think they've all got a place in the scheme of things, really. There's still a very big phone system over there. BT are moving over to VoIP themselves by about 2025, but there's always going to be people with conventional phones making conventional calls, or for many years yet anyway, and things like Skype have sort of slightly changed direction now. Microsoft have got involved, but yeah, there are lots of other ways to communicate, but this links in with all of it, and you can imagine bridging some of it as well. The thing about this is that you can make it do whatever you want. One thing I didn't mention, for example, was somebody making an incoming call to you, and you might want to route that to your mobile if you're out somewhere. Now that's going to cost you an outgoing call, but if they're cheap, then so be it. So it's very extensible. Anyone else?
You said
Yeah.
there was a book on Asterisk you recommend?
Yes, there is. It's you know the O'Reilly books. Yeah, it's an O'Reilly book. It's a 4th edition. Is the latest one. Yeah, definitely worth having. It's an excellent book for setting it up. Anyone else? No. Well, thank you very much. Okay.
Alright, we're going to take a break for 15 minutes. Just a quick question, if anyone hasn't signed in yet, can you please sign over the register over there? Let's go. Hello everyone. Right, we do the second talk. Right, so we've got Chris Willmott from Asterisk. Where you go?
Always works. Yes. Can everyone hear me okay? That's the first question. Excellent. So I'm doing a talk about managing technical debt, as you can see. So first of all, a little bit about me, because quite the large majority of you I don't think have met me before. Some of you know me, some of you know me for a very long time, so this will be a perfect opportunity to heckle from the back. I've spent about 16 years writing code in some shape or form. About 11 years or so in a professional capacity, so as a sort of full-time job. The last 4 years I've run my own company, a development consultancy. There's 4 of us, and most of the time we sort of help companies rebuild and refactor broken software. So we end up taking up all the rubbish that no other developer wants to touch. It's a nightmare. The last 2 years or so I've been mainly focusing on client side, so sort of consultancy roles, and that's been really eye-opening because with my background being in development, usually I'm on the technical side of things. Now sitting client side, you really start to understand and appreciate the stress and the pain from just wanting to get certain things done. So it's been a really interesting journey for me. That's some of the stuff I know and have touched and have worked on. I've just realised that's a bit zoomed out, that we can just do this. Some of them I'm not proud of. Don't look at WordPress or Magento. Some of them, so just about every one of these platforms, languages, stacks, I've had to come across a solution where I've either inherited technical debt or I've created some myself and I've kicked myself afterwards. So yeah, hopefully you guys will find this interesting. Right, so first, what is technical debt? Does anyone know what technical debt is? No.
Yeah.
Yes.
So it's producing a solution that you know you're going to have to go back and fix.
Yeah. Do you think you'd always know?
In my case, yes.
So voluntary technical debt, you're like, oh, I know
I'm doing it wrong, but this is going to get me over the line. So.
Yeah, no, cool. Before I go further, so I actually want to ask, so can I have a quick show of hands who is in a technical role, so writing code on a day-to-day basis? Brilliant. Is there anyone here who's not technical? Don't be shy. Fantastic. Come to the right place to do a talk. Nice. So it's her long time. Just a minute. Okay. So it's the long-term cost of temporary fixes is one way of looking at it. It's basically a contract with your future self. So, as you say, if you are about to solve a particular problem a certain way, you're embarking on a contract with your future self where you know you're going to have to fix that later. And it enables faster results now. Usually that's why you want to go and go through that shortcut or put that hack in place, is get some results immediately. Has anyone heard these before? I need the feature. Yeah. Just patch it for me. Can't we just something simpler instead? We need a cheaper alternative. This is my favourite. Quick, underscore old, it'll be fine. And then it breaks the build next time round. So hopefully everyone's kind of encountered these sort of situations before. So I want to talk a little bit more about the idea of borrowing from your future self and what exactly I mean by this. Because when we say debt, technical debt, you think, okay, what about financial debt? Can we draw a parallel between the two? Now with financial debt, the currency is cash. Okay, that's quite easy to get our heads around. With technical debt, the currency is time and effort. So you know that in the future you're going to have to spend more time and effort to fix what you've created in the past. But actually, time and effort, if it's a commercial situation, is money. So I always find this is a really good argument when you're trying to talk to non-technical stakeholders in your company. If they don't take it seriously, this is always a really good argument to put forwards. That any technical debt you accrue, especially if it's happening right in front of you, you as the developer, you see something happening, you're like, we really should be making people aware of this. Do say, yeah, by the way, this is going to affect us financially in the future. So a quick analogy, this was mainly going to be for if there was anyone non-technical in here, so I'm just going to do this very quickly. One of the analogies I try and give to someone non-technical is like getting the specifications for a bungalow and saying, are you sure you don't want it to be a bungalow? You're absolutely 100% certain. Yes, it's all signed off. So you build 3-foot foundations, build the first floor, build the roof, it's all fitted out, and then actually I want a second floor. Then you have to go back and you try and explain that, right, we've now immediately taken on technical debt, so we're going to have to underpin the house, go through the whole process all over again. Trying to find ways of explaining it is really, really tricky. So one of the things that you'll find when you encounter a situation where you feel you need to create technical debt is it's actually a shortcut. Now, one thing not to get confused with is efficiency. So I want to create a bit of an idea here. So like energy, we all hear at school and physics and stuff that energy is never destroyed, it only moves from one state to another. I like to think problems are the same. When you solve a problem, you're only moving it from one place to another. If you don't have a car, you want to go and buy a car to get around. you go and buy the vehicle, but you've now moved that problem to the manufacturer of that car company who has manufacturing processes, they've got to get that car to you. So you're just moving the problem to now someone else's problem. You can't make your journey faster without taking risks. So again, taking the car analogy, you've got a sat nav, you've planned in a route. The only way you can make that faster is to speed, maybe get a speeding ticket, maybe take an off-road road track, maybe end up damaging the car. So hacks and shortcuts are not the same as improving efficiency. So an example here would be if you say you had a new dual carriageway that you knew existed and you knew you could take that route. So you might find within the team, within the organisations, you're looking for new ways to make things more efficient. That's not necessarily taking on technical debt. So as people working on a day-to-day basis in front of code, what can we do to try and reduce the impact of technical debt, or to be aware that it even exists? It's an awareness of the inevitable. I think most commercial projects, you're going to undertake some amount of technical debt at some point during the process. So I'm going to take you through three kind of ideas. One is to try and think more commercially. I know most technical roles, you tend to be behind the scenes. You tend to not be right in front of the client unless you're freelancing, then it's probably very, very different. Building contingency, and I'm talking extra contingency from the I think this might take longer, and documenting risk. I think this is a really, really important. So I think the first thing is understand why you are taking on technical debt. If you have a scenario where, say, somebody wants a feature yesterday, and you say, actually, if we were to do this properly, I think this is going to take 2 weeks, and they say, well, we need it faster than that. So, okay, we can kind of bodge something together in a couple of days. By the way, we still need another 2 weeks after that to go back and fix it. And they're like, well, why is that going to take longer? And then explaining to them, we actually need to build in the time to refactor. So understand why you need to do that quicker, and then start to have that conversation with the non-technical stakeholders, so whether that's someone in your organisation or the client, and try to understand why do they need this particular thing so fast. And if you can try and get onto their side of problem solving, it makes it much easier to have that dialogue. Compromise knowingly. If you come into a situation where you feel that the only way out of a particular situation is a compromise, do it knowingly. So always make sure that whoever you're talking with, they understand what you're going through, they understand the amount of risk you're now bringing into the project, and make that really clear. If some cases, get them to sign off on it. So we're going to do this short, quick, hacky, dodgy thing. By the way, we will need to fix this in the future. Often what happens is it gets forgotten. Like, oh, you know that thing we did like 2 years ago? The temporary fix that's still there. A number of times that comes up. Yeah, communicate risk. I think that's so important. So one thing we've done at Pentascape is we've got this hack scale. So 1 is really dodgy, nasty hack that you don't really want to look at, and 7 is like textbook worthy of going into a framework. And we always try and be aware of like where we feel most comfortable on that scale. In some situations, we'll actually give 2 quotes. Certainly when coming up internally, we'll say, well, we think it's going to take 2 days to solve it this way. We're going to then inherit X amount of technical debt. We know we're going to need to fix in the future. Or we spend more time now and therefore have less technical debt in the future. And there's a balance between the two. But be aware of that scale. Be aware of not always wanting to do things so perfectly. There's really good time and place to put in dodgy hacks. Like if you've got a site that's broken and you need to fix it right now, then it's okay to just put something in right now, but know that you've got to come back and sort it out later. And inform the risk before acting on technical initiative. I think as engineers, we always want to feel we always want to fix it, want to get it done. But I think always inform whoever is involved in that project that that risk exists, and you're creating that risk at that point. Building in contingency. Now, anyone who's ever quoted before for how long they think something is going to take, it always takes longer, doesn't it? Pretty much every time. And it's always good practice to add in contingency. I think it's really healthy to do that. But I would add in another percentage for reverse contingency. So you add contingency for what you're adding now, but always add a little bit of extra time on to go back and refactor, or look at things you've looked at before, or go through all the to-do, fix, things that you've got in your code base. Documentation. I don't know how clearer to make this. This is literally probably the most useful thing. Now, we hate it. Everyone hates documentation. I hate it. But future you loves it. Because you'll come back to that code and go, oh, yes, I know, remember what this was. I know why this was here. Or especially if someone else comes along to look at your code, they're going to understand why you've done a certain thing a certain way. A number of times I've seen code where it's so condensed and there's lots of colloquialisms used in the code, or you'll see shorthand used, and it's like, leave that to the build process. The best code is self-documenting. So you've got declarations and methods that are very clear what they say, so when you look at the code, your IDE will do the rest for you, and you read it like a sentence. When commenting, I think this is also really important. Comment why something is the way it is, rather than what it is or how it works. So if you've got a block of code that carries out a particular function, don't just re-describe what that does. Takes this string and returns blah, because if a developer's looking at it, they can see that in the code. Instead say, I'm doing this like this because of this. Or here's a link to the Stack Overflow article that makes this insane thing valid. And try and include or enforce documentation in peer reviews. If you're working in an organisation where you have other people reviewing code before it goes live, build that into the process so you enforce that culture of always documenting your code. So when I say documentation, I am mostly talking in the place where we are all the time. So you don't have to write reams of extra paperwork. When quoting for work, always include the risks as well. So going back to my earlier comment, if you're being asked to build a particular feature or work in a certain way and you're under duress and you have to get this done fast, usually there should be a perfectly commercially valid reason why you want to do that. Make sure the risks are well known and bubble their way back up the tree so people understand, okay, we can do this fast, here are the risks. Are you comfortable taking on those risks? Identify and document common depth patterns. Now, I think most companies tend to work in particular sectors or areas, and you will see the same patterns coming up time and time again. Try and document them, because every time you have a particular scenario, you think, oh yeah, I remember we've come across this before. How did we solve this last time? If you've got a bit of a roadmap as to what you last did, every time you take on something similar, you will then be able to follow that, almost like a playbook, like a cheat sheet. Here's how we solve this particular problem. Have conversations. I know this is hard. If you're a freelancer, then come to events, discuss your problems online, show show what you've done, throw stuff on Stack Overflow, get other people to comment. I find drawing diagrams is really helpful. Often it's way quicker than writing loads of notes. You just literally, even if it's just a whiteboard with a pen and take a photo afterwards, sometimes a picture speaks 1,000 words and it's absolute gold dust. When future you is coming back to it, like, why did you do it? Oh yes, I remember now why I've done it this way. But be brief. I don't think you need to document things to death, but enough so that if you were to look at it again, or if you're run over by a bus and someone else comes into the company and are trying to look at it, they understand what you're doing. The flip side of all of this is not to go too far. Over-engineering is probably one of the biggest booby traps that you can fall into as an engineer. So where we're trying to think in terms of technical debt, like, okay, well, I'm going to work in a really conservative way. I'm going to try and remember as many times as possible to think, okay, I think this might end up being like this, so I'll build this in, or I'll write this eventuality and I'll make sure that it's going to do this. And before you know it, you've got so many different ways of solving that same problem, you end up with a rabbit warren of code that you now have to maintain. So finding the balance, I think a lot of people will find this very controversial, but I think good enough is usually okay. So when I say good, I mean do write tests, do check your code, do write good quality work, but just meet the requirement. Don't do anything more. Because when you start to do more, that's when you introduce extra bits of work for yourself in the future. You're like, oh, why did I do it like this? I should have done it like that. So we try and use arm's length future-proofing. It's very, very tempting to try and combat technical debt by trying to predict what's going to happen or where things are going to go. If you're in a commercial environment, literally anything can happen. We did a build for a startup about a year ago, and we are now in the process of practically rebuilding the whole thing because they've changed their business model. And there are a few things in there where like, oh, we've gone and built it in a certain way thinking it was going to take that trajectory. It still happens, and it's really important not to go too far into it, otherwise you'll find yourself inheriting technical debt the moment that business model changes. Yeah, avoid writing code for hypothetical eventualities. It's really tempting to do, and it feels really good when you're doing it because you're like, oh yes, it means that when I come to this in the future, I'm not going to have to do this again. Try really hard not to do that. Focus on now, focus on the functionality you're trying to deliver, do it well, do it cleanly, get it done. And I find that in the long run, eventually that pays off. If there is a requirement for future-proofing, make it a requirement. Do you actually document properly and understand with the client or the stakeholder, whoever's working with it, so you want this to be future-proof. Okay, we are going to make these predictions, they may not come true. You're expecting X amount of traffic, so we're going to go and do this. We're going to make it serverless. We're going to put it all in the cloud and it's going to be amazing. By the way, there's loads of extra code needed for the orchestration of all of that, which is going to be more maintenance. And then like, oh yeah, only 4 people are going to visit my app. So make it a requirement. And that also means in the future, if someone comes back to you and says, why do we now have to spend all this money to shift it across? You're like, well, that was a requirement, but we can't predict the future. So at least you've always got something to come back to. Sometimes technical debt is actually a design pattern. You do it on purpose. R&D, so deliberately going into the unknown. You've got no idea what's going to happen, and the outcome is, did it work, did it not work, what's out there, it's kind of testing the water. At the end of that, you might throw the whole thing away. Prototyping, again, very similar. Proof of concepts, this is basically what happened in our situation. We started out with a particular app, a progressive web app. It was built a certain way, and we found that after putting it in front of school children, it was a careers testing app. They said, oh, actually, it makes more sense for it to be like this. So you know that from the start. You're using it as a pattern. And minimum viable products. I think most of you may have heard of this term before. So going to market with something that is the absolute minimum, not only so that you don't spend loads of time writing extra features, you get it out into the market really quickly, so you take on the least amount of technical debt, but also you might end up changing it entirely. But that's okay, because you're better doing that with something really small than a huge, very big system that was a complete waste of time. Agile is your friend. Go and look up Agile if you don't know what that is. Communication is the key to all of this. I think empathy, traditionally and stereotypically, is really hard for people in technical roles to do. Usually you're there in front of them going like, this is ridiculous, why are we doing this? I know I'm right. Try and pull yourself out of that state and go, onto the problem side of it, the business side of it. Why does this person need this? They don't know what goes on behind the scenes. They don't care that you've had problems installing no package manager and you've moved across to something else. And they don't really not interested in all these different things. Try and understand what they want and why they want it. You know, you need this thing now. Who's going to be using it? Somebody, I want it working in all the latest browsers. Okay, well, who are your customers? Well, my customers are these groups of people. Why are you using, you know, I'll speak to your client. If they're using a crappy old browser, then just say, no, I'm not going to do it for that. Why don't we make it for your customers? Try and get into their shoes, understand their business, understand what they are trying to do. You'll find it much easier to communicate on their terms. Try and ask to see the bigger picture. I've been in situations before, there are a couple of people in this room that will nod their heads and verify, where as a developer you're hidden from like the next piece of work, and you're told, oh, we need to do the thing that's going to do this. You're like, okay, so you go off and you do that. And then you come back and then you go, right, now can you do this? Like, if only you told me that was coming. Now I've got to go and refactor a bunch of stuff. I don't know if there's this assumption that if you tell developers too much, they're going to start going off all excited and building all these extra things. But I think it's really important that you understand, as an engineer, what is the big picture? Where are we going with this? So that I have some kind of insight as to how to go about solving problems. So ask. If you don't ask, you don't get. Try and learn to speak non-technical. Like this is really hard, but it does pay dividends. It does pay off really well. And I've certainly found that when I'm talking to people who I know nothing about the technology, the less I speak about the technology, even though that's what excites me more, the more I'm able to have a conversation with them about building trust and explaining things like risk and why are you trying to do that, and oh, wouldn't it be better if you looked at it this way? You're not actually saying anything about it's going to be on, you know, Node.js, blah 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 blah, on this stack. They're not interested in that. Quantify. This is really important. Quantify alternatives. Again, coming back to this, so you want to do this now, that means we're going to need to do more in the future. How about we look at this instead? This is one of the best things about being a problem solver, is there are so many ways of solving one problem, and often it's not always with a technical solution. Sometimes someone will be asking for something like, can't Jane just walk down the corridor and do this? Like, oh, but that's a manual process. Like, sometimes that's actually fine, rather than just chucking something in for the sake of it. That is the end of my talk. Do you have any questions? Questions? Hello.
Earlier you spoke about contingencies.
Yes.
Now this is the debate of my life as well, because the projects always seem to go longer, like you said. How long do you usually put off for contingencies? And you mentioned refactoring, which I didn't quite understand.
So, yeah, one of the services that my company provides is taking legacy, gnarly bits of software, and we effectively inherit a whole ton of technical debt, and it's actually really hard to do that. But in most situations, if you're actually working on a project that you yourself have built, the percentage, I'd say, depends on the project. I tend to start with 20%, so if I think something's going to take a certain length of time, I then add more, sometimes doubling it, just for my, stuff might happen, then add another 20% for going back and fixing stuff from the past. Sometimes it works if you actually don't tell anyone that you've added that 20%. Does that answer your question?
Yeah, so 20% and 20% more.
Well, yeah, it depends on the project. If you've picked something up that is horrible, it could be 100%. It could be 200%. You know, so for every hour's worth of actual work you do, you're doing 2 hours worth of refactoring and fixing. Any more questions?
Sometimes the best option just to throw what exists away.
Try saying that to the CTO of a large organisation who spent a lot of money on their previous system.
I think that's one of the things that as a software engineer I learned, that you shouldn't get emotionally attached to your code.
Yeah, people do though. Business owners, I know what you're saying. Business owners get really emotionally attached to something that they've built, they've had commissioned or engineered, and when you try and pull them away from it, it can be very, very hard.
And another thing, how do you explain stakeholder that the prototype is a prototype?
And not the final project.
Well, because once they see something working,
They go, yeah, this is great, sell it. You know, like, whoa, it's still on, it's running from a Mac Pro in the back corner of the office. Go live.
Products which then are just a nightmare of technical debt for years. Just because stakeholders started working and it was instead that wasn't.
I think that's, going back to that point of, if you know you're going to undertake that risk, then I suppose you've got two options. You can either document that risk and tell them from the start, this is a prototype. At the end, we're literally going to throw it in the bin. And then we're like, why would we do that? Well, because we've spent that money. They'll probably say, yeah, okay, that's fine. So if you're trying to launch a business and it's reliant on a piece of software, so really sorry, you know, this is bespoke software. By the way, this is the only one that exists on the planet. No one's ever done this before. We need an extra 2 days. If I was a business owner, yeah, that's fine. As long as I had a valid reason, then yeah.
I think also the empathy is very important.
Yeah.
Trying to understand things from stakeholders' point of view and the non-technical point of view.
That's the hard day. It's hard. AI still.
I think as a software engineer, especially when you've been doing it for a long time, you just take so many things for granted, which is a very bad thing. So yeah, getting a clear perspective, a fresh perspective of things is very important.
And speak to peers as well. Ask other people, and you know, if you've got other people working with you, then ask them their opinion. If you're in a relatively large organisation, you've got other teams, go and speak to them. Yeah, definitely getting other points of view is definitely a good thing. Be more for any more.
When you talk about documentation of code, I work in the aerospace industry, so we have to use a specific suite of tools such as failure mode effect analysis, control plans, measurement systems analysis, system process control. What kind of documentation tools would you recommend using, sort of similar to that, and in terms of how would you go about documenting code in projects?
So documenting as in not in the code?
Yep. Or in the code, both. To avoid technical debt in the future.
Yeah, if it's in the code, I would say the documentation, the commenting should be like with the code that it relates to. But I would always include some kind of README documentation at the beginning. So if you've got source code, have a README file with all the details, or how to bootstrap a project. We've had this conversation at work a lot, where they say, why should I document it here? There's loads of documentation already on the internet. You're like, no, because what I want to do is literally load it up, install that, do this, go here. You just want to follow a cheat sheet. So that's those two methods. If it's not in the code, I would say it entirely depends on your organisation's setup. There are plenty of project management tools out there. Use those. We're big fans of Lucid Chart. We use that for diagramming. We use sort of Teamwork PM for project management, which includes files and notes against the project. So you can actually carry that information across. In the past, I've used Jira, which is fine if you're a massive organisation and you can employ someone full-time to work on the configuration. But they have something called Confluence, which is kind of like very simple stuff. Failing that, just a piece of paper, and like as long as you're making a note somewhere, I think that's key. I think we're done. We're good. I'm on various social platforms with you can see the pattern there.
Right, thank you, Chris.
No worries.
Right, so yeah, we'll be on for another 10 minutes. I just want to say a big thank you to the Quarter House for letting us have the venue, to the Creative Foundation for giving us, for sponsoring us. Also, once again, big round of applause for Bob Eager and Chris for tonight.